Students, this is Sivakumar, 10th Standard Mathematics, Chapter number 3. In Chapter number 3, so far we have completed up to exercise 14. For exercise number 15 will be taught later. It's a graph related problems. Then in the old textbook, next to that 15th exercise, you have that new concept matrices. The new textbook, the exercise number 16, that is also a graph that has been included. That's a special graph for you. For this year only it has been included. So now for the new book, exercise instead of 16 you have 17. Remember, for 16 that's a old book, 3.17 that is in new book. Same problems only. Okay, now we get into the introduction, new concept. Listen carefully. Now we are going to discuss about matrices. What do you mean by matrix? A matrix is a rectangular array of elements. The horizontal arrangements are called rows and the vertical arrangements are called columns. So remember, the rectangular arrangement is called a matrix. So again I tell you, the rectangular arrangements of the numbers or elements is called a matrix. For example, four, 8, 0, 1, 9 and minus 2 given. It's a matrix. Here we have two rows. The horizontal representation we can call it as row, vertical representation we can call it as column. This matrix has two rows, correct? How many columns? 1, 2, 3. So many examples are there. So what I have marked only you write. That is enough. Next, how to find the order of a matrix? Order of a matrix. Here is the definition. When giving the order of a matrix, you should always mention the number of rows first, followed by the number of columns. Okay. For example, I take this example. You consider as 1. Very simple. In this matrix, how many rows? Count the rows. 1, 2, 3. 3 rows. Columns 1, 2. 3 by 2. You are not supposed to say into. You have to say 3 by 2 matrix. Even though into symbol, you have to say 3 by 2 matrix. Okay, 3 2s are 6 elements are there total. You can count 1, 2, 3, 4, 5 and 6. Okay, next we can discuss about that different types of matrices. You start with the row matrix. A matrix which has only one row is called a row matrix. What is given? A matrix is said to be a row matrix if it has only one row and any number of columns. So a row matrix is also called as a row vector. So one example here, enough. So once again tell you, what I have marked only you write, others and all you no need to write. So for example, A that is equal to 8, 9, 4 and 3. Here in this matrix, how many rows are there? Only one row, even though it has 4 columns. So it is an example for a row matrix. Then column matrix. A matrix is said to be a column matrix if it has only one column and any number of rows. It is also called as a column vector. For example, out of these three examples, I have taken only one example, right? C, that is equal to, that generally in the matrix can be represented by any one of the English alphabets of capital letters. That's why you are given capital A equals capital B equals capital C equals, right? So capital C equals 8 minus 3, 23, 17. This matrix has only one column, even though it has 1, 2, 3, 4 rows. How many columns? It has only one column. Therefore, it is an example for a column matrix. Next one, square matrix. We know that definition of a square. Square, it has equals, all sides are equal, correct? Like that, a matrix which has equal number of rows and columns, that is called a square matrix. Okay, what is given? A matrix in which the number of rows is equal to the number of columns is called a square matrix. For example, you write both the examples. Here how many rows? 2 rows, 2 columns. Look at that, number of rows and number of columns are equal. Here also 3 rows and 3 columns. So these two are the examples of a square matrix. Next one, diagonal matrix. Diagonal matrix, listen, here is a definition of a diagonal matrix. A square matrix, it is a square matrix, all of whose elements except those in the leading diagonal are 0 is called a diagonal matrix. So what is given? So in a diagonal matrix, all the elements are 0 except the leading diagonal elements. Here is an example. It is a square matrix because how many rows, how many columns? 3 rows, 3 columns. At the same time, look at the leading diagonal elements. This is a leading diagonal. This one is a non-leading diagonal. Leading diagonal elements are non-zero numbers, 8, minus 3 and 11. At least one of the leading diagonal element must be a non-zero number. Look at the second example. Here other numbers are all 0. Look at that, 0, 0, 0, 0, 0, 0. So second example, look at the leading diagonal only, 1, 1, 0. Here we have 2 non-zero numbers. At least one non-zero number comes now, we can say that is a diagonal matrix. Other elements must be 0, 0, 0, 0, 0, 0, 0. So these are the examples of diagonal matrix. Again I tell you, diagonal matrix is a square matrix in which all the elements are 0 except the leading diagonal elements. Next one, scalar matrix. Scalar matrix is a diagonal matrix in which all the leading diagonal elements are equal is called a scalar matrix. Example, 3 examples are there. It is a diagonal matrix only because except the leading diagonal, the remaining elements are all 0. Except the leading diagonal, remaining elements are all 0. Except the leading diagonal, remaining elements are all 0. At the same time, look at the leading diagonal elements, they are same only. 4, 4, k, 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 5, 5, 5. So these are the examples of scalar matrix. Next one, identity or unit matrix. Identity matrix or unit matrix. Okay. Here square matrix in which elements in the leading diagonal are all 1 and the rest are all 0 is called an identity matrix or unit matrix. Right? You can see the example. Unit matrix of order n is written as IN. IN, n is the suffix. I have taken I2. I2 means identity matrix of order 2. Order 2 means 2 rows, 2 columns. That I3 means identity matrix of order 3. Order 3 means 3 rows, 3 columns. Look at the leading diagonal elements 1 and 1. Others and all 0. Here also 1, 1, 1. Other numbers and all 0. So these are the examples of identity matrix. Okay, or identity matrix of order 2. Order 2 means that is a square matrix, 2 rows, 2 columns. Order 3 means it is also a square matrix of order 3 by 3, 3 rows, 3 columns. Next one, zero matrix or null matrix. Then even we can say there is a void matrix, VOID. I note down here. Void matrix. A matrix is said to be a zero matrix or null matrix if all its elements are 0. For example, first matrix. Look at the first matrix. It has only one element. Order of this matrix is 1 by 1. That means 1 into 1. 1 by 1. You have to read 1 by 1 matrix. It has 1 row, 1 column. Look at the second example. How many rows? 2 rows, 2 columns. That is a 2 by 2 matrix. Then I have taken these two only 2 examples enough. Then look at the third one. Even you can write this also. It has 2 rows, 3 columns. What is the order of the matrix? 2 rows, 3 columns. That means zero matrix can be of any order. It may be a square matrix or even a rectangular matrix. Square matrix means number of rows and number of columns are equal. Rectangular matrix means number of rows and number of columns are different. That's all. Now, transpose of a matrix. The matrix which is obtained by interchanging the elements, it's in rows and columns of the given matrix A, is called the transpose of A and is denoted by A power T. So how to read? Read as A transpose. For example, write only one example. If A equals, look at that matrix, it has that what is given here, 3 into 3. That means 3 by 3 matrix, 3 rows, 3 columns. Just you have to find out A transpose. Therefore, A transpose equals 5, 3 minus 1 in first row, right in first column. Second row, 2, 8 and 9 in second column. Third row, minus 4, 7, 5 in third column. Just have to interchange rows into columns. That's all. Now, so only one example enough. Now we can go for that triangular matrix. A square matrix in which all the entries above the leading diagonal elements are 0 is called a lower triangular matrix. If all the entries below the leading diagonal are 0, then it is called an upper triangular matrix. Lower triangular matrix, upper triangular matrix. Look at the example. First one. In this example, look at these elements 0, 0, 0. It is an example for upper triangular matrix. For our upper triangular matrix, what is the definition? What is the definition given? Entries below the leading diagonal. This is the leading diagonal below which all the elements are 0. Leading diagonal below which all the elements are 0. It is an example of a upper triangular matrix. For lower triangular matrix, here is a leading diagonal. Above the leading diagonal, all the elements are 0. That is an example of a lower triangular matrix. Okay. Now, equal matrices. Two matrices A and B are said to be equal. if and only if they have the same order and each element of matrix A is equal to the corresponding element of the matrix B. So what is given now? If the two matrices A and B are equal, if the corresponding elements are same. See, A that is equal to 5, 3, 0 and 3 given. B that is 1 square plus 2 square. Here the first element is 5, it is also 5. If you simplify, you will be getting 5 only. Because 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. Then sin squared theta plus sin squared theta plus cos squared theta value is 1. You will be studying later. It comes in the chapter number, the new chapter, chapter number 7 it seems. It's a trigonometry. Sorry, that is chapter number 6, trigonometry. You will be studying later on. So remember, sin squared theta plus cos squared theta equals 1. What is here? 1 only. Then 1 plus 3 by 2, that is equal to 5 by 2. You know that because 2 ones are 2, 2 plus 3, 5, 5 by 2. 5 by 2 minus 5 by 2, if you simplify, you will be getting 0 only. What is here? 0. Then secant squared theta minus tan squared theta value you will be studying later on in the chapter number 6 trigonometry. That value is 1. 2 plus 1, that is equal to 3. Here also 3. So the corresponding elements are same. Then only we can say the two matrices are equal matrices. Okay. Now the negative of a matrix. The negative of a matrix A of order m by n, that means m rows n columns, denoted by minus A of m by n. No change of order, just you have to change the sign of the elements. Is a matrix formed by replacing each element in the matrix A m by n with its additive inverse. What do you mean by additive inverse? Listen. For example, we are considering a matrix A that is equal to, it is of order 2 rows 3 columns. Look at that suffix 2 by 3, 2 rows 3 columns. Minus A means very simple. This is called the additive inverse of A. Minus A means additive inverse of the matrix A. Very simple one. Just you have to change the sign. Plus 2 becomes minus 2. Minus 4 becomes plus 4. Plus 9 becomes minus 9. And 5 becomes minus 5. Minus 3 becomes plus 3. And minus 1 becomes plus 1. But same order only. That order of the matrix doesn't change. It is 2 by 3. It is also 2 by 3. Just you have to change the sign of each and every element of the matrix. That's all. The introductory part is over. I'll be teaching that exercise. Again I tell you, in new book 3.17. 3.17 in new book. I change it here itself. This is 3.16, 3.17. Okay. I start that exercise 3.17 in the next video. You just revise before getting to that exercise 3.17. Please revise the definition of a matrix, different types of matrices. Then only you can easily understand. Actually, it's one of the easiest part in algebra chapter. Very easy only. Okay, learn all the definitions and properties. Thank you, children.